Hello everyone, good morning one and all for the day 2 training section of IoT Webinar by IIoT Lab, PSNA College of Engineering, and let's start the session today. So based on the feedback received yesterday, so there are some issues like people were not able to fill the feedback form. So for those we have a instruction. So kindly ignore that day 1 feedback, those who have not yet filled, and we have posted the day 2 feedback over here in the description column, as well as individually it has been sent to mail. So kindly fill the feedback form after the live session. So since the unwanted participants or the fake participants are also registering to the feedback form, we have set the time limit for setting the feedback so that you can fill the feedback only at the certain time after the live session. The time of filling will be instructed to you at the end of live session. So kindly stick to the time and fill the form. Okay. So we can go to the day 2 as of now. So day 2, before going into that, we can just have some recap of day 1. So what are all the points we have discussed. So mainly we have discussed much about the embedded system myths and facts, and what are all the control methods of the embedded system, and what are all the methodologies do we need to call that as a node, a thing, or an intranet of thing, or what is mean by intranet of things, and how that get evolved as a internet of things, and what is the difference between IoT connectivity protocol and IoT communication protocol, and what is the comparison between the connectivity protocol and the communication protocols, and how a MQTT works, and what is the publishing and subscribing method of communication between a publisher and subscriber in a MQTT, and what is a broker, what is a topic, what is a subtopic, everything we have sorted out. And one more thing is, while we are doing the demo yesterday, many of the participants have complained that the resolution of the app mirrored in the screen is not good, so we have zoomed up and we have taken another alternative for that, and it has been resolved. Okay. So you will see clearly what are all the things happening over there, and since we have a little short of time, so I'm very sorry that you cannot join me in the live session. So only I can show you a live demo over there in the video, and after the live session you can able to practice those by seeing the video available over here in the YouTube link, as well as the tutorial what we are sending to you in the mail. And we have found that some of the attendees have done a spelling mistake or some grammatic error in your email, so those might not receive the emails properly. So if you want to have the materials delivered, so kindly give your proper email ID to the IIoT lab at psna.cetedu.in or info@bluetronics.co.in. Okay. So we can move to the next slide. And to have a brush up of the session MQTT, we can just let us know what is mean by MQTT. So MQTT is a message queuing telemetry transport protocol. It is a M2M, machine to machine protocol, where the primary thing is the MQTT broker, and inside this broker we will be having the topics, and this MQTT broker is nothing but a remote server or a remote IoT cloud, where our sensors or any clients can able to publish or subscribe to the topic or the subtopic in the MQTT broker. Okay. So assume that the sensor is publishing its water level value or temperature value or any pH value of some chemical, or soil moisture value, or the count of the boxes being packed in the industry under some topic, that will be reached to the MQTT broker, and what are all the clients who are subscribing to those same topic will get the information done. And here the information or the data which is published by this client can be of any data type. It can be with any JSON format, or it can be of with any uh, binary data or hex format or string or XML. It can be of any data type. Okay, so this is what we discussed in last session. So with that, we just stopped with the app. So from this point we can continue and we can resume the demo of the apps. Okay, so kindly wait for a minute. I will switch over to the app. So this is the app what we were using yesterday, and we have stopped at this moment, right? So this is the MQTT client app, and this is for the Android users, and for the iOS users you can use the MQT tool, and as given in the tutorial link, we have all the settings been done. We have switched over the enabled button, and we have given the nickname as Mosquito, and we have set the host name as test.mosquito.org. And here one thing I want to say to you, in the tutorial I have given you this link where you can find all the free brokers available. So you can use any of the free MQTT brokers available in this page for your academic projects and your any prototype or proof of concept projects, and you can use any one thing. Depending upon the server, any one broker may be with the free loaded, or it will be lightly loaded, so it will be more stable. So it depends. If more people are connecting to the same broker, then the server will be loaded heavily, so it can become unstable. So kindly stick to that. So if one broker is not working, you can switch to the next broker and you can try it out. Okay, so that's what I mean to say here. And coming back to the app, so we have done everything, and we have clicked that save also. So now we are going back, and I am entering into this Mosquito broker. Okay, so now my mobile phone acts as a client. So since I don't have uh, any hardware kit or any particular sort of Raspberry Pi board, so I am just giving a demo in the mobile phone itself. So tomorrow in day 3 I will be giving the same demo with the real hardware, with the real sensors, and with the real IoT cloud. Okay, so here, as you all want to have a practical exposure to this MQTT, I recommend to go with the app and to check how the MQTT really works. Okay, so these were the client window, and we have a client now. That means we are going to publish from our mobile phone. So there must be some area or device which has to receive this message, right? So we are going to set that part now. So for that, we are going to a platform called sensetechnic.com. So it is nothing but a Node-RED server. So I hope the CSE friends and the IT friends know much about this Node-RED. So Node-RED is nothing but a drag and drop kind of JavaScript tool, where without much of programming we can simply drag and drop and configure the tools, and we can set an application. So either that Node-RED package can be installed in our computer locally and we can work it out, or else if we have any Docker or if we have any server of our own, we can host this. But for the practicing and for the demo purpose, the company called SenseTechnic, they have given us a free account to make us to create up to 50 nodes for free. Okay, so we are going to use that SenseTechnic platform for our demo. So this SenseTechnic platform will be acting as device B, and our mobile phone will act as device A, and we will be using any MQTT broker like HiveMQ or Mosquito or Eclipse or Flags as a MQTT broker, and now we are going to publish and subscribe to the topic. So before going into that, I would like to explain how to use the Sense Technique platform. So I hope you all have created a free account in that. So I'm going to log in with that free account. So once you log in for the very first time, this will be the window displayed over in front of you. So the first thing you need to do is start instance. So just click the start instance so that your Node-RED instance in the server will get configured and it will be loaded. Okay. So just wait for 2 or 3 minutes, and this depends upon your internet speed. And once this has been completed, you will be having a configuration window at the left, and you have the Node-RED application window to your right. Okay, so you will be finding an arrow button over here. Just click this. As of now, we no need to configure any. So here you have some kind of an example already deployed over there, right? So what you need to do is you just ignore this. We can go to this add new column, and in the add new column you will be getting a new page. So if you don't want to have this sheet 1, and if you want to delete this, there is a simple way. Just go to the menu, and in menu you can find the flows, and you can find here a delete option. So if you click this delete option, then that particular sheet 1 will get deleted. Okay, so now you have only flow 1 here and there is no sheet. Okay, so now here we can find lot many menus. So we have some functions where we can write our own data conversion from Celsius to Fahrenheit, or we can even split the values, or if some values coming over there in MQTT, we can set a trigger back, or here is a plugin for MQTT input and a plugin for MQTT output, and even there is a WebSocket, and there are some output columns also where we can able to see the dashboard data, like button. For example, if you press a button, so if you press a button, value can be triggered to the MQTT. Okay, so there is some other thing called slider and a numeric input, and there is a text input, there is a color picker, and you also have some kind of dashboard tools like chart, gauge, or other things. So we will be using this as of now. Okay, so now the first step to check whether this platform is working or not, we can just take this inject column and drag and drop into the application window. So this will just inject some random thing. So here it is going to inject the timestamp over here, and we are going to drag and drop the next thing called debug, and it just blankly exposes the message what is been receiving. So to connect the two things, just click the end of the first node and join it to the end of the second node. Okay, so this is how it's get connected. So now if you want to change any settings, or if you want to configure in this, just click this so that you will be getting all the parameters. So if you want to change anything inside this, you can do it. Okay, so once you finish your flow, you can go to the deploy and you can click deploy over here. So if there is any error, it will show what is the error over here. If there is no any error, then it will say successfully deployed. Okay, so now you just go and click this debug messages icon. So once you click this, you have to come over here and you just reactivate the message payload. Okay, and now you start injecting the timestamp. Okay, so since I started injecting the timestamp, I got my timestamp being displayed over here. So this is nothing but Unix timestamp format, and this will not be the right time as shown over at the top. Okay, so we have to convert this Unix timestamp into hours, minutes and seconds, and there is a formula for that. So this is just to check whether this platform is working or not, and it is working fine. And now we can go with our MQTT tool. So we can just select all and we can delete this as of now. So the first thing is we are going to subscribe to a topic. So coming back in the AnyDesk, we have used the broker test.mosquito.org. So we can use the same broker over here. So double click, and here we are having some option, add new MQTT broker. So go to the edit window, and in the edit window we just give the name mosquito and the server name as test.mosquito.com. Make sure there is no grammatical error or any other spaces in between. All those things, you just check it out, and it itself says to leave blank for client ID. I'm just giving something blue, random client ID to this, and I'm going to click add. Okay, so now under what topic I'm going to subscribe? So I'm going to subscribe under the topic name PSNA. So from my mobile I am going to publish the messages under the topic PSNA, and in this platform I am going to subscribe the topic under the subscribe the messages under the topic PSNA, right? So if there is any error, there will be a small red color triangle projecting over to the top of this box. So if there is no error, then you will be having a blue link over here. Okay, so this is the setup of the MQTT input. That means you have successfully subscribed to your topic, and to check it we can go and drag and drop a debug window. Okay, so in the debug window we can check whether we have received any messages under that particular topic. So I'm going to connect my debug window with this MQTT input. Okay, so everything is fine. So in this I'm going to click deploy. So I got your comments. So okay friends, I will adjust my speed. I'll go a bit slow. Okay, so we have deployed this, and it says connecting. So let's wait for some moment. So if it's not connected, then we have to add any other broker and check. So which one is working fine, we can switch to that. Okay, so this is the procedure. The first procedure is to come to the left pane, and in this you can find, in the network column you can find the MQTT input. This is for subscribing. MQTT output is for publishing. So you have to drag and drop this particular thing, and you have to click that twice. So you'll be getting the properties window, and over here we have to go over there and edit the broker details, and this broker details should be same as the one you entered in your mobile phone. Okay, so you have to give the same broker details, and you have to give update. So once you give this update, then it will let you to enter under what topic we have to subscribe. So for example, I have given the topic PSNA, and I'm clicking it down. So it's still in the connection pane, so we can switch to other broker. Let me change the broker. Yeah, so I am just switching to the broker MQTT Eclipse.org, and now it is connected. Okay, so let me come back to the mobile phone, and in the mobile phone let me create a broker window for Eclipse, because we have only Flux and Mosquito, right? So let me add one more broker by clicking this plus symbol. Okay, so we have to enable this, and we can give some nickname. So in the nickname we can type Eclipse, and I am giving OK, and in the host I am typing MQTT dot eclipse dot org, and I am giving OK, and I am going down, and I am setting my client ID, some random name, test. Okay, so I have entered all such things, and the final step is to save the server. Okay, so now I got a broker window for my new site, so I'm just clicking that. So it's now connected. Okay, so it's now connected. Now subscribe to the same topic PSNA. Oh, sorry, we have to publish, right? So we have to click this button, up arrow mark, and we have to publish some messages under the topic PSNA, and the message is hello all. Okay, so in my mobile phone I'm just typing the message hello all, which I'm going to publish under mqtt.eclipse.org under the topic PSNA. Okay, so I'm just clicking the publish button, and now we can come over here, and we can check whether we received any messages. Okay, so let me wait for some moment. Yeah, so now in my mobile phone I have given the publish, and here I have received the same message hello all. So to check, so this is my topic, and this is my message, and this is my broker, and I have just given publish over here. So I received this message hello all. So now I am giving this again. Okay, so it may take some time to reach depending upon the network. So it depends upon the network, so whether we will receive it too fast, or it may take some time. So now I am sending another one message called IoT. So first I send the message hello all, and now I am sending the message IoT. Okay, so this is how we can able to send the message from one device, and we can receive the same message by subscribing to the topic from other device. So here the complete concept is I have subscribed to the same broker mqtt.eclipse.org, and I have subscribed in this platform Fred, and I have published the message from my mobile phone. So this is how MQTT platform works. So if you are all having your mobile phone, and if you are subscribing to the same topic PSNA under mqtt.eclipse.org, so whatever message I publish here, you also will receive. So this is how from one device I can able to push the messages to thousands of devices or 10,000s of devices. So now we can add another one small piece of thing to the dashboard. Okay, so I'm going to include a gauge. Okay, so I'm going to include the gauge, and I'm going to add that to the MQTT input. Okay, so a gauge is nothing but a simple meter kind of visualization tool where we can able to see our data, right? So we have to configure this gauge, and we have to add this to the new UI group, and I will let you know what is mean by the UI group. Okay, so first we have to add a new UI group. So I'm going to set a name to the UI group, IoT Webinar. Okay, so I will just explain what is this UI group while showing in the visualization tool. So just now I am adding a new UI group, IoT Webinar. So I am setting the limit. It is 0 to maximum is 10. I am setting that limit to some 100. So I think some of my friend or one of our participants have used and send a hi message to all. Okay, so hi anonymous friend. So once the settings been done, we can click done. Okay, and we have the error. We will check it out. So it is unassigned. So have to click the tab also. We can give it as under home. Update. Done. Okay. So now everything is been done. So whatever the message I am sending from my mobile phone will be reaching this node, and it will be displayed over here using this message payload column, and also we can able to see the gauge too. So, okay, so to see the visualization, we need to go to another one sub web path. So for that, you just note it down the company name. Okay, so you just note it down the company name. Even for your account, it is will be some company name, whether it will be your name of your college or something. Okay, so you will be giving this detail during registration. So you have to note down this company name and open a new tab. So my company name is IIoT PSNA. Followed by this, you have to type Fred.Sense Technique. So this is nothing but the same website name. Okay, so this Fred.sensetechnique.com is the same website name. We're going to put over here. Okay, so my company name followed by the Fred.sensetechnique.com followed by API followed by UI. UI is nothing but the user interface. So this is the web link what we use to describe the visualization tool. So what is the visualization tool we used? We have used a gauge, right? So that's the visualization tool. So I'm going to see that visualization tool via this web page. One second. Sorry, I haven't deployed it yet. So I have successfully deployed, and I'm refreshing the page. Wait a second, I will just check what is the error happened. Okay, there is some connectivity issues with mine. Kindly wait a second, I will check it out. Some network issue in my side. Okay, let I try with other account. So I have one of my colleagues' account also over here. So let I try with this and check whether it has any error. So I'm going to change this to the broker MQTT dot eclipse dot org, and the topic should be PSNA. Okay, so it's now got connected. And let me check, the gauge is under webinar 2 group. Okay, so I have to, this organization name will differ for each account. So for that account it was IoT Lab PSNA, or here it was Priya 303. So while registering, it will ask for an organization name. So whatever the name you gives in the organization name tab, that will be displayed over here, and you can use the same. Okay, so just copy that and yeah, so this is the webinar 2, and this is the gauge what we have put for the content. And here one thing I would like to explain. So I have given something called UI group, right? So I have declared a new UI group. So the UI group is nothing but a group under which the visualization tools will be categorized into a single pane. So you can create different groups, like you can have this as your a group called energy, under which you can give your voltage, current and power values, and you can have another one group where you can give the any other parameters like pH value. So what will be the pH value of milk, what will be the pH value of water, what will be the pH value of the chemical you are going to use, like that. You can group the visualization tools into different things. Okay, so with this I am going to send some value to the PSNA topic. Okay, so I am typing PSNA in my mobile phone, and I am just giving the input as 3. So I have some connectivity issues over here, so it's disconnected. Yeah, now it is connected. So this will work only if you have a good internet connection with you. So due to the network issue, I am just repeatedly getting disconnection. So I will try some other broker. It is getting again connected and disconnected. Okay, so I will just try some other broker. So this is also getting disconnected. So let I switch to some other broker then. So depending upon the network and loading of the server, the brokers may get loaded. So we have to check whether which one is the right. So I'm going to check the third one. Yeah, it is getting updated for broker.hivemq.com. So even in the mobile phone, we will go back and add broker hivemq to our panel. So at the final step, I am clicking the save symbol, and now I got this broker 5MQ. Okay, so I'm going to publish under the topic PSNA, and the message is some number between 1 to 10. So I'm just giving some 4. Why I'm giving the message between 1 to 10 is I have set the gauge in this account as 0 as minimum and 10 as maximum. So that is why I'm giving some value between 1 to 10. So for an example, I'm giving 4. So this was my message, and I'm going to publish. So let me check whether we got this message. So some network issues with this. So once I receive the 4 over here, I will be having the gauge switch to the 4 here. Okay. So some connectivity issues. I'm getting again and again disconnected like yesterday. So if there is the connectivity issues fine, then I'll be receiving the value over here. Okay. So in the gauge, I have grouped it under webinar 2, and the range I set is 0 as minimum and 10 as maximum, and so it is categorized under webinar 2, and the gauge's value is 0 and 10. It says it's successfully connected, but the messages, due to some internet connectivity, it is not reaching over here. So this is how we can check the working of the MQTT platform. So I'll be sending the tutorial of this to you after the live session, and you kindly check it out. And if you face any issues, kindly put up in the mail. Okay. So for the broker, I have given the list of broker in the mail what we sent you today to all individually. So you can use any of these brokers and you can try it out. Okay. So anyhow, I will just post the tutorial, right? You can find all the information in the tutorial. And we can come back to the next thing. So the Internet of Things, we have seen some basic aspects about the MQTT and how it works and what are all the possibilities to check. And if you have two mobile phones and if you install this MQTT client in the two mobile phones, then you can check it how it works. Like from one mobile phone you can publish and you can subscribe in the second mobile phone. Or if you want to use the platform to check, then you can go for this thread, unless otherwise it is needed. So if you have two mobile phones in your hand, then you can use any of your father's mobile or your brother's mobile. Then you can take that and you can install the same app in that mobile, and you can send and receive, and you can check how the MQTT protocol works. So next is, while we are combining this MQTT platform or this Internet of Things along with the industrial standards, then we call this as industrial Internet of Things. So for example, Internet of Things is a common generic concept, but for any application, they have tailored this Internet of Things into their own architecture, and based upon the application they have included some protocols. For example, if you are using a IoT for healthcare, then it will be called as HIoT, healthcare IoT. So if you are going to use this IoT for any kind of defense, then it's called DIoT, defense IoT. If you are going to use this for any industrial and factory purposes, then it is called IIoT, Industrial Internet of Things. So in the left side you can see the explanation of the IIoT, and in the right side I have given a small picture showing the evolution of the industries. So till 1969 to 2000, we have all the automation done with PLCs and electronics and computers, and this is where we have the Internet of Things enabled. Okay, so after 2000, people started to migrate from Industry 3.0 to Industry 4.0 standard, with the inclusion of the Internet of Things and also other concepts like your artificial intelligence and your data analytics and other big data, all such things. Okay, so right from Industry 4.0 era, that means right from 2000, industries are migrating to the IIoT standard with Industry 4.0. So what is this IIoT standard and how it is used in industries? So this is a small depiction of the complete industrial architecture where we have many motors or any actuators and some kind of sensors. So all these were connected by different protocols, right? So the sensors and other valves and robotic arms, everything is being connected by Profibus or EtherCAT or OPC UA or even our MQTT what we use right now, and all is being connected to a gateway, and from there it goes to the edge processing. So yesterday many of the participants have asked what is mean by edge processing. I will explain this in the coming slide. So from there it's going to the cloud, and if it was a private cloud only the factory can access, and if it was a public cloud then all the other peoples can access. So with this data they are going to calculate their production and quality and other material system, everything in the ERP. Okay, so this is how they integrate their business tools and the artificial intelligence tools and the IoT with their existing intranet of things, and that's how IIoT evolves. Okay, so in yesterday's session we have discussed some IIoT communication protocols like data distribution service DDS or AQMP or MQTT, like that, right? So here you have AQMP and you have MQTT taken from the normal normal Internet of Things, and this OPC UA is OPC for Unified Architecture. It is a industrial standard. So like this many industrial protocols like this EtherCAT or IO-Link or CAN-Open or Modbus has been included over here. So one advice to you all is, if you are selecting your field as the IoT, and if you are going to explore yourself in IoT, whether you are a student, if you are planning to do some projects, or if you are a doctorate staff doing some research on IoT, we advise you to go with this industrial IoT, because there is no such better research carrying over, and it is one of the area where many people are yet to come and to do the research. So if you are interested to do some works in IoT, or if you want to publish some paper, this will be too good. But there are some points what we need to discuss in this IoT for industrial application, that is the time of response. So as I said to you earlier, if there is a boiler, in yesterday's session I said this example. Okay, so in the boiler, if you need to measure the temperature, it has to reach the cloud within the fraction of microseconds. So if this is having some delay over there in reaching the cloud, and if there is no action being taken over there, then the boiler may explode, right? So that may give some huge damage to the plant. So to avoid that, we need to go for time critical protocols. So if the time is very less, so within some fraction of time, if we need to send the messages, then DDS protocol, data distribution service, and OPC for unified architecture is the best one. So if the time is between 10 millisecond to 1 second, that means it has the option to receive or send between this particular time interval, then MQTT or OPC UA is fine. And if the time interval is greater than 1 second, then advanced message queuing protocol, AQMP, is preferred. Okay. So now coming to the edge computing. Edge computing is nothing but it's also a small server that is being kept at the node side itself, or a thing side. Okay, for example, I need to send a group of temperature values from 40 to 50 ACs in a shopping mall, and I need to send that to the cloud. So assume that I am a manufacturer of a particular air conditioner brand, and in the world I have lots and lots of my products selling all over, and I have a single cloud which is installed in my headquarters. So now if all the lakhs of ACs is sending data to my server, then the server will get loaded, right? So for this particular problem, to resolve that, and to reduce the load of the server, we are going to pre-process the data at the node or the thing side itself. So along with the node and gateway, we are going to put one server, and the data collected from the gateway is going to process, and it has to store, and it is going to get converted into an encrypted form by the industry, and all such processing is done over there, and then only it is going to send to the cloud. So that equipment or that type of computing is what we called as edge computing, and the devices what we use over there is edge computing devices. Okay, so this is what basically we called as edge computing. So even this whole same for the IT or CSC standards also. So edge computing is nothing but the computing done at the thing or the node level of the IoT, and where all the pre-processing is done. For even for example, if you take a energy conversion from kilowatt to kilowatt, or from Celsius to Fahrenheit, or we want to process and send the data only if the data goes beyond 100, then only we need to send the data to cloud. Such type of process will be done at the edge computing level itself, so that the server won't get loaded heavily. So by this method, I can able to save the loading of the server. I can able to have the control over the data in the edge node side itself. So this is the main purpose of edge computing. And when it speaks to the CSC or IT standards, here all the machine learning or all the deep learning or all the AI training models will be running in the edge computing, and only the results of these AI, ML or DL will be sent to the cloud. So this is what the people will do for the CSC or IT standard. So for example, they are running their Kubernetes, or they are running their Docker, or they are running their other AI or ML trained models with the TensorFlow or PyTorch, and all the pre-processing will be done at the server level itself. Only the output of those will be sent to the cloud server. Okay, so this is how the edge computing works with respect to the CSC or IT people. Okay. So next, coming to the artificial intelligence and machine learning. So why we are going to learn this for the topic Internet of Things? Because just getting the mere raw data is not a good thing. So we need to analyze the data with some predefined algorithms. So the more we train the data, the more the better results we get. For example, for the past 3 years, I am getting the data from a particular office room, and in that office room, a fan is having some problem every December. Let us assume. So I have an office room, so where I am going to collect the data of all the devices over there, like tube light, fan, switchboard, whatever it may be. So in that, a particular fan is creating me a problem in every December month. So in this past 3-year data, I am giving that to any artificial intelligence algorithm or machine learning algorithm, and I am training that model what I got as a result. Okay. So as a result of that, if I give my test data, my real-time data to that now, it will compare and let me know that in month of December, you might have a problem in this particular office room due to this load, due to this particular reason. So like that, we can able to predict the fault before it happens. So this is one of the good use case of implementing the artificial intelligence and machine learning. So another one thing is, if the values goes beyond the threshold, like below some value or above some value, that also I have to learn from the previous data, so that I can able to get that. Okay. So the two main things what we are discussing now is predicting the faults before it happens. That's what we called as predictive maintenance. So that is what we call as predictive maintenance. And the next thing is, if the values goes beyond the threshold, then we have to detect that as abnormal event. That's what we call as anomaly technically. So that's what we call as anomaly detection. So this anomaly detection and predictive maintenance are the two main applications of artificial intelligence and machine learning in IoT. So this is where all the bigger companies like Amazon or Azure or Google or even a company like Bluetronics is working much upon to give a better solutions. So assume that we are all purchasing a particular brand fridge and all the fridge data is going to the manufacturer's cloud, and some of the people is having some issues with the fridge. So this data is being read, and it can now predict that only in the area of some particular parts of Tamil Nadu, due to this low power, the fridge may get repaired in this particular month, or due to rain at this season, the fridge may get repaired. Like that, it can predict the fault before it happens. So that is what uh, the main thing or the main implementation of this. Okay. So we are going to have a small demo of how to train the data with this anomaly detection and all those algorithms, and how to see the fault and how to predict the fault. Okay, so we can go for the demo. So we are going to have the demo in the IIoT. So this is also a free account. So after this live session, you can also go to the particular website and you can follow the same procedure and you can practice. And for the participants who is repeatedly asking whether this PPT is available or whether this video is available, so at each end of the day, this live video is converted into a video and it will be available in the Bluetronics link or the IIoT Lab YouTube channel. Okay, so you can refer this video whenever you want, and the presentations for all the 3 days will be sent to your individual mail at the end of day 3. Okay, so and the tutorial, like what we are going to do now, everything will be made as a tutorial, and that also will be sent to your individual mail ID as we sent today morning. Okay, so in this website called Edge Impulse, you just create a account. Okay, so just go and sign in, and or you just sign up and create an account and get verified from your email. So to your email they will be sending an activation link. You have to click that activation link, and you have to come back over here, and you have to enter your credentials. Okay, so for some of the participants who complained that their data has exhausted due to the time delay, so I am very sorry for those people, and I apologize for the time taken yesterday, and I again apologize in advance that I am going to take further 10 more minutes of you to complete this demo. So this is the starting page of your IoT data analytics website. Okay, so here you will be having some menus like dashboard, devices, and all these things. So let me go one by one. So first we need to go to the devices. Okay, so for all these demo you can use the live embedded hardware, but since that is not available with all of you, I am going to show this demo with the mobile phone itself. So how to keep your mobile phone as a IoT device and how to perform all these live practical examples. Okay, so once I click the device, you have a menu called connect a new device. Okay, so you just click this menu, connect a new device. So in this you have an option whether you can use your own embedded board or you can use your mobile phone, and if you have any other data sets taken from any other MATLAB or any other software and you have stored those as a CSV format or XML format, then you can take those data sets and you can get imported over here. And this menu is how to port the result to the hardware. Okay, so that we will deal it later. So I am going to use the mobile phone, right? So just click the menu, and now you use your mobile phone QR scanner to scan this link. Okay, so I am now scanning now. this particular link. So every participant and every account, once you got registered, you will be having a link over here. Okay. So once I just scan the link, here I have a smartphone.edgeimpulse.com being displayed over here, and I have a notification connected as phone K9S00VMF, and you can collect the data from this device. Okay. So now we can go to the next page. Okay. So now we can go to the data acquisition tab. So here I have my phone number being displayed, and I am going to start the sampling now. That means we are going to take the values of the accelerometer. Okay, so it has two options. Either we can get the value of microphone or accelerometer, but since accelerometer gives more values, I am going to use that. Okay. And before that, let I check whether in the device pane I got this thing listed. Oh, so many members have connected. Okay, that's why I got the confusion. Okay, so this is my phone, and I'm going to start the sampling. Okay, so now in my phone, I'm getting this notification like recording data. I'm moving my phone here and there, and it is now getting uploaded. Okay. So now you can see the accelerometer data, right? So what I did, I just clicked start sampling, and I choose the sensor accelerometer, and once I clicked that, I got a notification in my mobile phone, and it starts recording for 10 seconds. So for that particular 10 seconds, I just move my phone randomly, and I got some accelerometer XYZ values being recorded and stored. Okay, so now the next step is to create an impulse. Impulse is nothing but a tab where we are going to choose any one of the machine learning algorithms to train our data. Okay, so here we have 4 tabs. So it itself will automatically detects what is the input we have given and what is the input stored over here, and what is the input we have to choose over here. For example, I need to analyze only X value. I can check this and I can uncheck the accelerometer Y and accelerometer Z. And this k-means anomaly detection is the k-means algorithm. I hope you know well about this. And I'm going to save the output. Okay, so I'm going to click save impulse now. So by this, it has successfully stored the impulse. So now I'm going to take the raw data, and this is my raw data that's been captured. Okay, so this is my raw data. So I'm going to have my window over here. So this particular portion is nothing but your Hamming window or Hanning window, what you read in your digital signal processing. So you are going to set a window, and using your k-means algorithm, you are going to put a filter over here roughly, and you are going to get the values. Okay, so if I just set the windows over here, so the values will be updated. You got it? So this is after applying the ham window. So and after applying the filter, this is the processed values, but I am going to take some values with disturbance because that will give much better result, right? So I am going to save this parameter. Okay, so I am going to use this particular set of values. So once those values has been saved, it will be plotted in 3D. What is the x value, what is the y value, and what is the z value. So if you are using many mobile phones data, then you can have all such details been given over here. Okay, so these are our friends who have connected just right now. So the participants are also connected to the same QR code, right? So all these things has been given. So we can even compare and contrast different values. For example, let me assume we have some 30 robots going in some forest area. So each robot's X, Y, Z value we can compare and analyze. So the next thing is we have to click generate features over here, and by clicking the generating features, it will generates the value. So it says job completed. Okay, so it is generating the features from this. Features is nothing but what is the maximum threshold, what is the minimum threshold, what is the most disturbed value, what is the least disturbed value, everything. Okay, and now I am going to select all these data. So this example is just to let you know that how IIoT values is being retrieved and how we are applying any machine learning algorithm over that IIoT values. So if you have some temperature sensor values, or if you have some IoT values that has to be processed with some kind of machine learning algorithm, so how we need to do that. So for this I am doing this example. So I am starting the training now for my anomaly detection. So once I click start training, I got the training output over here. Okay, so I got the training output and it says job completed, and now we can go to retrain this saved model. Impulse means it is just a group of tools where you can import your k-means algorithm or any other algorithm, and you can convert your raw data into DSP results. Okay, so you can apply your DSP filters or windows on that, and you can take up the output. So that is where the impulse tool is being used. And after that we have the raw data now, and we have the anomaly detection data. We have to train the model, and once the model is being trained, it says job completed without any errors. So we can now go for live classification. Okay, so I'm going to connect my phone again. So with the trained data, I am going to give the live data now. So with this it will compare and say whether my values are above the threshold or lower the threshold, whether it is normal or abnormal. Okay, so just click start sampling, and in my mobile now I am going to record the data. It starts recording for 10 seconds. Okay, so now we can come back. It is classifying and testing. So now anomaly detection algorithm is running at the back end, and this is my raw data what I captured now. So when I compare this data with my already trained model, it says 98 are abnormal values and there are 0 normal values, because when you compare this with the older data, the most of the lines were normal, right? But here I purposefully shake the mobile well, so that I don't have any proper 0 values or null values. All the values has been shaken to the maximum extent, and so when you compare this, at any moment of time it says all were abnormal. So by this I can check what is the abnormal values and what is the normal values. Okay, so you can use the same to compare and contrast your energy data or your chemical data or your mathematical analysis data or the time taken for compiling your software code. Any kind of analysis can be done with this. And once this has been done, we can go to the deployment, where it itself will generate a C++ code for you. Okay, so this is the demo for implementing the AI or IoT in sensor model. And regarding the feedback and the tutorials, the feedback form will be opened by 11:30 and it will be closed by 12:15. Okay, so to avoid the fake participants registration in the feedback form will be opened by 11:30 and it will be closed by 12:15. Those people who may miss this time, kindly stick to that and try to fill the form between this 45 minutes of time. Okay, so the feedback form will be opened only by 11:30 and it will be closed by 12:15. So I request the participants to fill the form. So this is the live session as of now, and if you have any doubts or if you have any clarifications, and many people have asked me what is mean by OPC or what is mean by AQMP. So if you have more details on that and if you want more clarifications on that, kindly give us a mail to info@bluetronics.co.in or any IIoT lab at psnacet.edu mail, so that we can give you or share you more details regarding those. Okay, so this is the very basic of how to use a MQTT and how to use IIoT with machine learning analytics. So tomorrow you will be having a live demo on hardware, and using a hardware how to send a data to the cloud and how to control your hardware's equipment from the cloud. All those things we are going to see. And as I promised in day one, we will be learning more about the IoT hardware platforms and IoT software platforms tomorrow. Okay, so I thank you all the participants for being in this session today, and don't forget to fill the form between 11:30 to 12:15. Okay, so if there is any thing to ask or if you have any query, kindly mail us. Okay, so all the feedback links and details, everything has been sent to your individual mail ID. So those who haven't received, just mail us back, and only the participants who attended the live session are requested to send the mail. And with humble request, don't share the feedback link to any of your non-participants or your friends. Okay, so thank you one and all for participating again. We will meet tomorrow for day 3 with hardware live demo and discussing the other details. Okay, thank you.